Okay, all right. So today what we're going to do is this. Based on by the way, hopefully when if everything goes smoothly, today will be March 1st, Monday, and probably if I remember correctly, will be the last day of cohort C together. Okay, I think. So what we're gonna do today is this. Based on last Friday's lesson on systems of inequalities and testing solutions, I want to use today to present to you some of the Regents questions regarding that. Okay, so it's a very specific set of questions. Systems of inequalities and testing the solutions in them. Okay, so let's take a look. Okay, all right, so let's see how this goes. Let's see. I wonder actually. Hold on, I'm trying to think what homework it would be by the time we get there. Doesn't matter. All right, so there are 5 questions here. Um, Video wise, I think I'm gonna do the same thing. I'm gonna go over 10 minutes to maybe 15 minutes worth of questions, and then the rest I'll make them optional viewing, and then you can do your homework. Okay. All right. So let's go with it. All right. So here, let's start right here with number one. Okay. So I picked five. I found 5 questions. I didn't pick them because that would assume that I had like a choice. But these are the 5 I found. All right. That's related to what we're doing. So, okay. All right. One. What is one point that lies in the solution set of the systems of inequalities graphed below? All right, so here's the graph. What's one point that's in there? Okay, so let's just test it out. All right, so I'll use different colors. Let's see, 7, 0, 1, 2, 3. By the way, that is an actual Regents questions. I'm just gonna tell you that now. Like, you know, it seems straightforward, but you know, they do want to know if you know how to do this. So 1, 2, 3, 4, 5, 6, 7. That looks kind of good already, actually. All right, what is it? What is one point? Yeah, that looks kind of good. All right, let's use a different color. I'll use a thicker pen. All right, 3, 0, 1, 2, 3, right here. Now, that's no good, right? Because this line is dotted. So it does not include the blue point as a solution. All right, so this is no good. What about 3? 0, 7. 0, 1, 2, 3, 4, 5, 6, 7. It's on the line, but it doesn't really matter because it's only the solid line anyways, right? It's not part of the solution, all right? And lastly, what is that? Negative 3, 5. 1, 2, 3. Wait, no. 1, 2, 3. 1, 2, 3, 4, 5. No, definitely not. All right, so that leaves us with 1 as the answer. All right, okay, what else? Let's do 1, 11, 15, and 16, 17. We'll look at the time. All right. Okay. All right. 11. And so, okay. All right. So number 11, right now, I'm going to choose the two. I'm going to choose the two that are whole numbers first. Okay. Just because it's easier to deal with whole numbers than fractions. So I'm going to test this out. Okay. So what I'm going to do is I'm going to substitute. I'm going to write this with the y and the x substituted already. So like that. Okay. And then for this one's y, so that's 6 is less than negative 6, 0 plus 4. Let's see. All right, so here, if that's the case, then this is 12. All right, again, if you have a notebook, this is easier, okay? 0 plus 4 is 4. That's not true. 12 is not less than 4. Let's see. So there's no point in testing this, all right? Once it's wrong, it's wrong. You know what I'm saying? So no need for that, all right? That's not it. All right, let's try the second one. All right, so here I got 2 times negative 3. Ay, ay, ay. So here I got 2. The 2's from this, okay? The y is 2 less than negative 12 times negative 3 plus 4, right? And then let's see, the y is 2 less than negative 6x, so that's negative 3 plus 4. Let's test these out. Okay, hold on. All right, so let's see. So I'm gonna write a little smaller here. You know what? I'll write it up here. So I'm doing this one here. So 4 is less than now. Negative 12 times negative 3 is 36. 36 plus 4 is 40. So is 4 less than 40? Yeah. And then let's try this one out. Okay. 2 and then 18 plus 4 is 22. Is 2 less than 22? Yep. So that's it. There's our answer. Okay. So in other words, there's no need to do these two fraction ones. Okay. All right. Let me erase this. Okay. All right. 15. Let's see. So number 15. So which order pair is not in the solution set? You just plug it in. So I think I'm going to stop after this and then make the last two optional. All right? Because I made a mistake earlier and now I don't know how much time I've used. Okay. Now, it says which one is not in the solution set. So you got to pay attention there. Yeah? All right. So not in the solution. So let's see. Well, there's only one way. I mean, these are all whole numbers. So we just got to, uh, do it. All right, so let's see. Y is 3. I'm doing the first one, okay? Y is 3 is greater than negative 1/2 of 5 plus 5. And then the second statement is Y is less than 3 times X, which is 5 here, minus 2. All right, let's see. Let's hope both of these statements. Let's hope this is wrong. So that will make us the answer. All right. So 3 is greater than now. That's negative 1/2 of 5. That's negative 2.5. Negative 2.5 plus 5 is 2.5. Right? Hold on one sec. Okay, and then the second one is 3 is less than, go to 15 minus 2 is 13. So they're both true. So that's not good for us because we want one that's not true. So that's not this one. Okay, let's move on to the next one. All right, I'll do it on the side here. All right, so let's see. So 3 is greater than negative 1/2 of 4 plus 5. And then the second statement is 3 is less than or equal to 3 times 4 minus 2. Okay, all right, let's see what's up. 3 is greater than negative 1/2 times 4 is negative 2. That's 3, right? And then, so that's no good already. So this is the answer, okay? 3 is less than 12 minus 2. 3 is less than or equal to 10. That's true. So this one is true. This one is not. But that makes this not true. Okay? Now, technically, I got to tell you. So because these things are on the regions, I would actually suggest to you, all right, for you to plot these 2 points. Maybe I should take the time to do this right now for number 3. Okay? So it might occur to you that you might be better off plotting it instead of plugging this in. Um, I would agree with you on that, actually. So what I mean, right? So let's graph these 2 lines, right? Let's see, negative 1x, 1/2 x plus 5. So let's see. All right. Negative 1/2 x plus 5. And then the other, now this one is actually greater than, so I'm going to change the thing. What happened? Oh, I'm stuck again. I can't believe it. All right, and then the second one, let me press pause. I don't want you to have to wait for me. Is it done? All right, so it's greater than, right? Is it greater than? I can't see it. All right, greater than, yep. So let's change this. And then the second one is 3x minus 2. I'm going to change this to less than or equal to. Okay, all right. All right, graph that. And then you could look at it, find the solutions, right? So look, 5, 3, and I could trace it too. 5. Yeah, 5, 3 is within that purple area, so that's why it's good. Okay, look, that's 5, 3. So that's why we had to cross it out, because that was the solution. All right, let's go to 4, 3. Oh man, it's stuck again. Hold on. Now, the thing is, 4, 3, it's on the line, but remember, that blue line in the first case, it's a dotted line because there's no equal sign. So notice how this is dotted. By the way, this is not dotted, okay? Not dotted. This is solid, but it's supposed to be dotted, all right? Imagination. So no, you can't just sit on that line. So that's why this is not the solution, okay? Then that's why we chose 2. Okay, all right. So here's the part where I think we should stop because this is probably 10 minutes. All right, let's see. Hold on, let me see. All right, okay, so I determined to keep going. So there's no second video, optional video today, okay? Because I think if we can do this in 5 minutes, then we're good. The video should be about 15 minutes for today. All right, okay, so let's read. First, consider a system of equations. I'm just gonna write it down. All right, so systems of equations, y equals to the negative half of x plus 1, and then y equals to x minus 5. And then by using different colors, I also have a set of inequalities. Now what? When comparing the number of solutions in these systems, guys, I mean, I pretty much know what the answer is because in the systems of equations, typically you have one solution, right? Remember that? Whereas here in the systems of inequalities, unless you get one of those weird things where there's none, like no solutions, right? In general, you're gonna have way more solutions in inequality, but we don't know yet, so we have to prove it. Okay, so here's what we're gonna do. We can graph both of these. Okay, so let's do that. So what I'm gonna do is I'm gonna press pause and graph it for you just to save a little bit of time. Okay, hold on. By the way, just so that we understand each other well, the question is basically saying which one of these systems, the systems of regular equations or systems of inequalities, have more solutions. Okay, so we're going to explore that by graphing it. Now, the line's a little thin. I totally forgot, but it's okay. All right, so look, there's one solution here, right? So this set has one solution. All right, now let's see what this set brings us. Oh, these are the same equations. Nice. All right, all I have to do is change the symbol, right? You see that, right? These are equal signs. These are inequality symbols. So one's greater than, one's less than. Okay, all right, let's see. Let me change that. The first one's greater than. The second one's less than. And the lines, neither line is solid. Okay, they should both be dotted, actually. All right, so let's see. Yeah, I mean, look at this purple area. Look at all the solutions in this purple area. So it has to be choice 3. All right. The systems of inequalities have more solutions. Now, again, right? So one of the things I want to emphasize is there are exceptions to this because sometimes you might get 2 lines that have no solutions, right? Or this one, it might happen that this one might have infinite solutions, for example, if they're the same equation, right? So you gotta keep your eye out on that. You can't just make that assumption right off the bat. Okay? All right, last question. And then we'll call it a day. All right, 17. All right. Determine if the point 0, 4 solution. I mean, it's right here. 0, 4, right? 0, 1, 2, 3, 4. No, it's not a solution, but how do you justify your answer, right? Like, how do you tell them? It's kind of tricky. You actually need to know the formula for this line. Here's why. Because they gave you this formula for this line. So you need to know this so that you could plug in 0, 4 into both of them. Okay? So it's not as simple as saying, well, we graphed it. The point 0.04 is in one shading, but not in the other. I don't think that's a sufficient answer. So now that means we need to find the slope-intercept form, right? So here we got y. Now let's get the main part of this down. So the y-intercept's plus 2, right? See that? That's the y-intercept. And here the rise is 1. The run is 2. Rise, overrun. So it's 1/2 positive plus 2. See that? That's not hard, right? And then here you can see that the line here, this line is shaded down, so it's less than, and it's a dotted line. So no equal sign. Okay? Not that hard, right? Now you will substitute. So here we got the first equation. Here we got the second equation. Now, since we already established that this is not the solution, the only thing you'll have left to do is to prove it by substituting 0, 4 into both of these. And you see that it works for one but not the other. And that's how you prove it. Okay? All right. I got to run to class. So that's it. Okay. Thanks for watching. Have a good day. See you tomorrow. Bye bye.
OMG, that was so good.